Hi everyone, we're back with 5 project ideas for full stack development video. I've done this video before, but one very specific thing has happened in the past 6 months. We now have an AI. So you have a tutor to help you out. And the way that I've structured these assignments is that I've written very nice prompts. So the things that you do not understand, you can ask ChatGPT to build, but I would prefer that you write them yourselves. These are 5 ideas that are slightly more than full stacks. These are actually clones of websites, but these are not simple websites. They don't have the basic user signs up and does something. They have some special moat. So I want you guys to build that moaty thing, that thing that has the moat. And the reason is because that's what differentiates a very good software developer from an average full stack developer. So without further ado, let's get right into the video. The 5 ideas are right here. I'm going to explain the idea a little bit, show you the website maybe, and then specifically tell you the difficult bit to build here, the bit that's more than full stack development. What is that protocol that it uses, how you can learn about it, and how you can write that specific part of the code. That will be the most difficult bit. Everything else, the basic structure or skeleton of the app will be the same for all 5. But the thing that's very difficult will be different for each and every of these. The first one is called a StreamYard clone. So if you've seen this website called StreamYard.com, it basically is a website that lets you stream from your browser to YouTube. So if you go to YouTube and try to create a new live, you can you get back something called as an RTMP URL, and using this RTMP URL, you can give it to StreamYard and you can stream directly from your browser, and you can add more guests and friends to this. You can also put in overlays like this. So it's a pretty cool sort of a website. They were fairly big. They were a 2-people team that sort of, I think, reached like $8 million in revenue and then finally got acquired for $250 million. So pretty good business during COVID. And they had one very big moat. The moat was it's very hard to do browser to RTMP. And that's what they did. So other than all the basic things that you need to do here, the important thing is this backend service too. The service that takes your input stream and the current set of overlays. So an overlay could be a text somewhere, your name at the bottom, or a comment that the user posted, and it needs to be forwarded to YouTube's server. So the scope for this project is that you don't need it to be multiplayer. A single user needs to stream from the browser to YouTube. So the way this usually works is when you're in the browser, you have a canvas where you can put your stream or pull it out if needed, and you can put some sort of a text overlay somewhere here, let's say. This video stream then needs to go from your browser to a backend server, and this backend server needs to convert this input stream for whatever format it might be into this format called RTMP, which is the format that YouTube understands. The same goes for Twitch. Both YouTube, Twitch, other streaming platforms, they all give you an input RTMP URL. And RTMP is hard to produce, well, impossible to produce from the browser. So you need a service in the middle that converts this input stream to an RTMP stream. The question now is, what is this input stream and what does it look like? It can either be a WebSocket stream, which means you convert all your video packets here into some sort of video encoded data. Then you send it to the backend service, and the backend service converts the video data to RTMP. This is not optimal. The optimal way of doing this is taking input in WebRTC. So this is a UDP based protocol that lets you similarly capture, and so you have to capture the video similarly, but you're going to be sending it not using WebSockets, which is over TCP, but using WebRTC. How do you do that? In the browser, you have very simple constructs that let you do it. So on this side, it's fairly easy to do. If this is your browser, it's very easy for you to convert a canvas video into a WebRTC output stream. The difficult bit is writing the server-side logic for it, which could be either in Node.js or usually it's in Golang, where you're able to capture this input WebRTC stream, decode it using something like FFmpeg or GStreamer. So it's FFmpeg/GStreamer, and then send it to YouTube. How do you do that? You figure it out. I will be doing one of these projects at the very end. So you can let me know whichever was the most difficult one or that you want me to build in the comments. I will do it at the end, and also time box it to 1 hour. Cool. This is the first one, StreamYard, and this is the basic system design for it. And the most difficult bit is this part. Everything else is simple. Again, you have prompts here. So let the user sign up, all the things that you need as a functional requirement, and the 2 services and what kind of tables you need to create if you're using an SQL database. Okay. Project number 1 is done. Project 2 is Google Docs. I don't need to go too much into detail here. Google Docs is a fairly simple application. The only thing that's difficult here, well, there are two difficult things. One is when you're writing something in Google Docs, and if someone else has the same doc open, they need to see this data in real time. For that, you can use something called WebSockets that let you send and receive data in real time. There needs to be a server in the middle. WebSockets is not a peer-to-peer protocol. So if there is one browser here, there's another browser here, there needs to be a server in the middle that relays this information to all the users who are subscribed to that specific Google Doc. So if I put some text here, it should go to a server. From the server, it should be relayed to the people who have opened that doc. The other difficult bit here is avoiding clashes. What if I am writing something on some line, the other person is writing something on the same line, and we're basically writing it not just at the same line, but at the same cursor point. I write hi here and someone writes hello. How does this collision sort of eventually reach the same state? So either we reach hi, hello, or we reach hello, hi, or we sort of reach some combination of it like H, H, I, E, L, L, O. But whatever the case be, they should eventually be the same. How do you solve this problem? It's solved using something called operational transforms, which is something you can read about. That is what is the mode of this business and the most difficult thing to build in Google Docs. Cool. Moving on, a Google Meet clone. So we've done StreamYard, and I told you guys that in StreamYard, the way to send video from from the browser to the server was this protocol called WebRTC. And this is also the protocol that's used in real-time communication between browsers. What is Google Meet? It's an application where I see my video here, and if someone joins the same room, I see their video as well, and people can screen share, I hear them as well, so on and so forth. This media communication between browsers can be done by WebRTC. As I said, WebRTC is a construct that your browsers understand, so it's actually fairly easy to do. You do need a server in the middle. That's usually called the peering server or the signaling server. Yeah. But after the communication has been established, you can basically send packets between browsers as long as you're in a decent network and not in a very restricted network. If you are in a restricted network, you need to send media through what's called a turn server, but you don't have to worry about it. You'll just be testing it locally. This is also not the right architecture to do video applications. You shouldn't be sending video peer-to-peer because this doesn't scale very well as 5, 10, 20 people join your call. But this is a good start. This is where you should start. What do you need to do? Other than building the basic blocks of the website, you need to facilitate communication between everyone who's in the same room, let's say room 1, and you need to push video from this guy to all the other people in the room, and this guy should also receive video from all the people who are in the room, also screen shares and also audios. Cool. Given all the jazz here, more things are in the README. Try to read through it and create a simple peer-to-peer Google Meet. Moving on to fourth thing, Google Drive. Google Drive is simple, right? I think it's probably the simplest to implement here because we have very nice object stores right now, like S3, and GCP also has one, I'm forgetting. But you can basically just outsource storing the data, which is the most difficult bit here, like creating a file system that's sort of reliable. So you basically need a website where users can upload a file. Let's say there's a limit over here called 1 GB, and this video / audio / whatever file this is should reach S3 directly. That's the difficult thing to build here. Most people, when they build such a system, relay this information via a server of their own to S3. And the problem here is you don't want like a 1 GB file to reach your server and then go to S3 when S3 provides you a way to send it directly to S3. Now, to make it secure, you need to make sure you don't put your right AWS credentials here, because then your AWS credentials are on the client side and you don't want them exposed there. So there's something called pre-signing that's used here to build a system like this. You get a pre-signed URL from AWS through your backend server. So a request goes to your backend server. I need to upload something. It creates a pre-signed URL using the AWS key that it has, and you get back the pre-signed URL, and you use this pre-signed URL to finally upload chunks one by one to S3. This is how I upload my videos on my course selling website as well. It's like a very famous architecture to upload videos to S3. So that's a basic architecture of Google Drive. Then you just need to create shareable links. Lastly, LeetCode. I've basically created a full stack series on this. We've built everything here, the front end and back end, which are simple stuff. The difficult bit, which some guy actually did and won a pair of AirPods as well, was running someone else's code in a containerized fashion on a server, and it should auto scale. So this is LeetCode. Simple stuff is you allow user to put their code here, and there's a submit button. with this problem description here and test cases here. Okay. When the user clicks on submit is when the most difficult part of this business sort of kicks in, which is a request goes somewhere and it needs to run in a very containerized fashion, in either a Docker container or a Nix container or something else, so that this end user, whatever code they've sent, doesn't blow up your instance. If you have a single instance that's running your main backend and maybe serving your main frontend, and here you run this user given code, the problem is you can blow up the user's backend and frontend, and it's like a very famous vulnerability. So how do you fix that? You containerize the end user's submission. You also need containerization because you need to give some certain level of sort of limits, as in 4 GB RAM, or like 1 second is the maximum time that you want this specific code to run. And you have very nice constructs to sort of allow that in Docker. So if you want to, I can also link the final solution that someone built, but that was built using Kubernetes. So some of you might not understand it. There are easier ways to do Docker orchestration if this is the first time that you're doing this. So you can try that. It's basically as simple as taking the input from the user, maybe putting this in a queue, and then having workers that can pick elements from this queue one by one and run the code in a containerized fashion. Make sure it doesn't run for more than 1 second. If it does, return a TLE or store a TLE in the database. If it gives the right output for every input test case, then put an AC in the database. If it gives wrong output for any one input, give a WA and put it in the database. So fairly simple stuff, most of it. Those were 5 projects linked in the description. Let me know which one you want me to build, and I will create a 1.5 to 2 hour video where I'll try to time box and finish all the functionalities. I think all of these are not too difficult to build, and you can build them in 2 to 3 hours. I will personally try to build them in max 2 hours. Which one? You guys can comment below and let me know. But other than that, I would urge you guys to do it yourself. The repo is linked in the description. If you have any more questions, let me know. I'll see you guys in the next one. Bye bye.